Howdy, it's tubalcain again, your YouTube shop teacher, and this is tips number 535, which is part 6 of the restoration of the Mead 1x42-inch band sander. Thanks for joining me and thanks for watching my video. So let's get on with the build, and I'll continue with where I left off the other day, and be sure and go back and watch those other parts. Before I get on with the video about the table for the Mead band sander, I want to back up just a little bit. Do you remember the other day when I took the clip off of here, and it was one of those Parker Kalon hairpin, and I lost it. I heard it go twang, and I decided I'm not messing with that. I'm not going to find it, and I'm going to use one of these instead, and I still am sticking with that. But I did find it. I wasn't looking for it, but look where it went. It flew clear over the lathe and clear over the bandsaw. How it ever could have been over there, I do not know, because it must have bounced off of several things. And of all things, as I was picking up scrap here, why, there it is on the ground. A couple of things now. As I was looking through the archives, I did find some footage where I was working on the wooden pattern for this, but I decided that it just had no place in this video, so I discarded it. But before I start machining on this, and as I'm talking about irrelevancies here, I think I'm going to show you, when I found that clip, I also found the clip of Tommy the spite mower, and I simply have to show that. Also, there's some green grass in there that is pleasurable because now it's white outside. But let me show you Tommy, and then I'll get back to you, and I'll be over at the Bridgeport mill, and what I'm going to be doing is machining just a little bit off of the slot, off of the other one now, not this casting, but off of the other one, because that slot was not quite wide enough the way I had sawn it out. Sawn or sawed, to fit across the platen. So I'm going to widen that just a little bit. Then I'm also going to take the milling machine and mill, pretend this is the cutter, 45 right here, so that the table can be tilted, and you'll understand that a little bit better even if you do not right now. So alright, cut to Tommy, and then I'll see you over at the mill. There is Tommy, the spite mower. See him waving at me? He's posing. Note the setup here. I'm on 2 parallels, so I won't mill into the table. And I've got it clamped. It may not look secure enough to you, but remember, I'm just going to be doing a little bit of milling here on soft aluminum. And I wanted this pretty well squared to the table, so I just took a parallel here, got it up against this surface on the table, brought the work up against that, and that assures that I'm pretty darn parallel. Now, in the last part of this video series, I said that I was going to mill both sides of the lug. Well, I'm thinking way back to the Peterson Products days in that little sander that we used to make, and it was located by that. So that's not really necessary here, but I'm going to go ahead, as long as I got it set up, and mill just this side of the lug, only so that it takes the pattern draft off, and that when I drill that hole through there, the drill bit does not deflect. Possibly no need for that, but I'm going to go ahead and do it anyway. That's a 3/8 long end mill. Now I'm only, the way I sawed it, a little over an inch. And I want to be 1 inch 200 thousandths approximately. I'm using only a 3/8 diameter end mill because I wanted to minimize the radius in the corner here. because I will probably have to come back and file that corner. And I got about, what, 90 thousandths to go. So I'll take another pass. I won't show it, and I will climb mill on that for hopefully a little bit better surface finish than what I have. Be sure and wear your safety glasses now when you use any machinery in your shop. Okay, I've got the slot just the right width, pretty decent surface finish. Now when you make a setup like this, make sure that you have plenty of clearance between your spindle, your quill, or whatever, and your clamps. And I did take a dry run. Always take a dry run to make sure that you're going to clear. And there is clearance there even though it doesn't appear to be. That is why you'll see on many milling machines, including this one, that the nose of the spindle here is all polished up and tarnished and all that. That's from running into the work or the clamps or something like that. Even though it's hardened, you'll see marks on it. Well, the next thing I need to do is to put this angle right here. Now there's got to be 100 ways of doing it. How would you do it? Now I had to put my thinking cap on for this one. Well, again, there's a lot of ways of doing it, and I probably will not do it this way. And by the way, tilting the head wouldn't really work. Think it through and maybe you'll realize that, but I'm not going to talk about that. This is a piece of waste stock. That's just aluminum, and I have it in the vise at 45 degrees. And I was thinking about clamping the work onto this and then milling right down here. Also, this is a piece of waste stock. It wouldn't matter if I milled a little bit into it because I don't want to mill into a good piece of material or the vise or any other part like that. Well, I don't believe I'm going to do this operation by this means. Just showing you and thinking out loud again. And the vise isn't even held down. So let me show you another way. I think this is the way I'm going to do it if it works out with the clamping. I've had this adjustable angle plate, if you want to call it that, I don't know what you call it, for some years, and I'm just dying to use it. It's not real big, it's 4 inches, and I've already set it for 45 degrees. And this is made by Eclipse in England. I always was rather impressed by the Eclipse products. So I will clamp this to the milling machine table. I got to make sure it's square. I'll check it with a square, and I'll put a couple clamps or T-bolts. It's probably easier to use those big yellow clamps than if these are relatively small slots. And then the game plan here is, just like I showed you before, to put the work in there like this. Could be either way for that matter, couldn't it? You ever notice this shiny material just doesn't photograph well at all? You'd think it would, but it doesn't. So, you know, I don't want to mill into this valuable fixture. You won't be able to do this by this method because there's probably only 2 people in Illinois that own one of these. And where did it come from? Well, guess. So I squared up the fixture like that. And by the way, I talk a lot about Starrett, I talk a lot about Brown and Sharp, but do not shortchange yourself on these beautiful measuring tools made by this company, Products Engineering. I think they're up in Minnesota. And tighten down the clamps real well. Whoops! You know, there was one guy who's a troll. He said, I will never watch your videos again because I had used an adjustable wrench backwards. Remember, it's not a crescent wrench unless it says so on the handle. Okay, here's the setup. Now I know this is a bit precarious with only 2 C-clamps. There is a piece of waste stock. I know it's going to chatter like crazy, but it's a relatively small and I hope sharp end mill. So I tried to make some other C-clamps fit in here, and it just wasn't working for me. So I'm going to give it a trial cut here and see what happens. And there probably will still be a little material that needs to be removed with a file or abrasives. All right, actually that worked too good to be true. I'm shocked. Again, a 20-minute setup for a 2-minute cut. Now, of course, Mead or anyone with any sense at all would realize that the pattern maker would have done that in wood, and that angle would have been cast in there and no need to machine it. Let's go over and see how that's going to work. Back at the bench here, I think there's still some of you wondering why in the world did he do that? What is the point? Well, the whole point is that when the table is up against there, if that is not relieved, that's a relief. You would not be able to tilt it. I can't get the camera back in there to show that to you, but look at the difference now and think about it. Why I did that, and it'll become more apparent here in a few minutes. Also, I had worried about the radius in here. Remember, originally I had it squared out quite nicely. You know, I worry about things that I shouldn't be worrying, because in the end, those radii aren't going to hurt a blame thing. I'm going to insert a little bit of a non sequitur, as it is my wont to do. Recall in an earlier video I told you that there wasn't any crown left on this lower wheel, that it had been abraded away by the dust over the years. And I thought, well, that wheel isn't going to work. It's not going to track. I probably will have to either make a new wheel or machine some draft on it. But as you can see, when I ran this thing, that it runs and tracks just fine. Again, I was worried about nothing. And then again, to put a little levity into this rather drab video here, there are hundreds of people out there that are saying, you know, you're a moron. You got a band sander. Why didn't you just sand that angle in there with the band sander? There couldn't be a more appropriate and perfect tool like this. And yes, that's going to take some time and may not be all that accurate. It would work far better with a real coarse, this is number 100 grit belt, but that would be a great way to do it, wouldn't it? This is perhaps a bit of overkill. This could be done in the drill press, although I want the work held down because it's a 7/16 hole I'm drilling, so I just have one yellow clamp. By the way, I like these right height clamps, don't you? Holding an angle plate, which is about a 6-incher or 5-incher or so. And looking at it from this side, you can see that I've already laid out and center punched the hole where I want it located. Now, there isn't room for a chuck. The chuck would strike right here. Different solutions. One, use an extra long drill bit, and I got plenty of them. But you know what I'm doing, that's a standard drill bit, and I'm holding it directly in a 1/4-inch collet, and then I'll switch to a 7/16 R8 collet for the final size. You know what? Eisenhower was in the Oval Office last time I used a 7/16 collet. Well, the table is done, but how am I going to mount it? Well, here's how. Pretty much the way Mead did it so many years ago. I wonder if there was a Mr. Mead. Probably. All right, there's a 7/16 hole drilled right here. So I'm going to take a 7/16 bolt. Now, hey, have you noticed that most fine thread bolts are grade 8 or grade 5? This is a grade 5. You can't saw them. You can't do anything with them. So I'm not going to use that, but I did find one in my bolt bins that is soft. I've already cut it off, so there's not too much thread on it. And I put a jam nut on there. Well, why am I using a fine thread? Only because the only jam nut that I had in a 7/16 was fine, so that's why I'm doing it. Well, now, and that'll go in like that. And another nut tightening it down, and that's just a stud. That's all it is a stud. How long does it need to be? Well, I don't know. I'm going to cut it off there. Maybe I'll cut it off again later. And I'll do that with a hand hacksaw. You don't need to see that. I'll be right back. Alright, looking at the parts list now. That's the table. Now they used a bolt to hold this piece, you can see the dotted line there, and a clamp. It's a split piece. That's what I'm going to make right now. So they used a bolt, a little bit different design, with a nut on the end, and I could have done that, but, well, this is my own design, I guess. Then this other stud here, part 33, will go into the table, probably also with the thread, and be clamped on here. This piece can swing and allow the table to move at an angle and in and out so that you can find the sweet spot where it belongs. And anyway, it gives some adjustment to the whole thing. So I'm going to make this part, 17 there, out of this 1/2 inch wide. I milled it down to dimension, and there'll be a 7/16 hole right here. And I don't know what the distance is, so I think I'll make a wooden mock-up first to see what the distance is and then cut it off. Then there has to be some slits here, like you see here, along with some screws that will allow it to clamp. Okay, much time has elapsed and much redesign has been instituted here. So forget everything I told you about fine threads and this bolt and what I'm going to do here. And this is my sample piece. It's going to be held in by a 7/16 course for that matter, and a nut. It's a little bit longer than I thought and a little bit thinner. Now looking upon the table here, several things. First of all, I drilled the hole, and I got a cross hole for a set screw drilled in there, and I think the original was made that way as well. Then I also lacked clearance right here, so I milled that slot in there so there'd be clearance for this. Now furthermore, upon examining this piece here, notice that there are 2 set screws, and there is a slot all the way from one end to the second hole so that it will pinch part 33. So I'm going to make this out of metal now. Metal, it's steel. That's 3/8 by 3/4. Forget about this piece that I spent a half hour on the other day. Drill the 7/16 holes in there, make the slit, make the set screw threaded holes and all of that. So I'll be back in about a half hour. You don't need to see any of that. Alright, it's about 45 minutes later, and this part is way too complicated, but evidently that's the way they made it. Also, I don't like how much overhang they have. Me. Well, that's the way they designed it. And when I look at the way Delta made it, and I've owned Deltas, their system really was far simpler and far better. But this is a Mead, and that's what we're sticking with here. Now, that's what it looks like. This is really just an entrance slot. It would have been nice to cut the blade and weld it, and or go back and TIG weld that, blah blah blah. But notice now, this will tighten up quite nicely, and then this one will tighten up on the shaft over here on the table. This is too long. I may cut it off, but I'm holding it at that length for now because that may be a good point to attach the belt guard. So that's a possibility. Also, this 7/16 rod is too long, I believe, at this time. Can always be cut off. Again, there's a set screw there, and I just milled a flat on this piece as well. Always mill a flat, otherwise you end up with that mushroom in there and you have a heck of a time getting something disassembled. Alright, you can see we've got plenty of clearance. Now do you see why we have a swing arm? It can be squared up like that, and to some extent you can force it down without loosening these up. Now watch this gap here widen as I tilt the table. That again is the purpose of that angle that I put on there. Now let me show you how to adjust that. Now to adjust it, I tilt it and then move it in like that at whatever angle I would want. This is the principle of the whole thing. But here's my objection to the design, and here's the improvements I would make. There's an awful lot of overhang here, and that would cause a lack of rigidity. Of course, I don't have these tightened up right now. A lack of rigidity. But that is their general design. If I had this to do over, to make the pattern over, I would move the lug a little bit farther over here. Also, I would make the lug a little bit longer in this direction, so that there wouldn't be any interference here where I had to make this slot. This can be cut off right here, and I think I will, but I'll hold off on that one. Well, that pretty much concludes this video for today. So be sure and watch part 7, where I will tackle the swing arm for this other wheel. It'll hang down about here, and maybe do a few other touch-ups, and perhaps that'll be the last chapter of this very long video series. Hope you enjoyed it. This is tubalcain saying so long for now.